Welcome to qnawire.
So now I'm going to work on problem 74 from chapter 13. In this problem, we're asked to calculate three concentrations, molality, molarity, and mole fraction for the 8% mass, 8 mass percent ammonia solution, which is commonly found in households. So the information that we're given in this problem is that we have 8.00% mass of ammonia and water. And the density of this solution is 0.9651 grams per milliliter. So in this problem, what we need to do is we just need to select a amount of solution to do our calculations with. We're not given any particular volume, so let's just select it and do the calculations accordingly. So we're going to need 5 different parameters to calculate molality, molarity, and mole fraction. The first is the mass of ammonia. So again, we can calculate this by multiplying the percentage times our total mass. So we'll select that to be 100 grams. And then we have 8% as mass of ammonia versus 100% for the total mass. And we do this and we get 8 grams of ammonia. So we need to do all our calculations with this value in mind. So then we need to calculate also the mass of water. We'll need that for molality. So our total mass is 100 grams. Our mass of ammonia is 8 grams. So our mass of water will be 92 grams. So we'll need moles of both. Moles of ammonia for all 3 concentrations, moles of water for mole fraction. So we have 8.00 grams, and we just need to divide by the molar mass, which is 17.03 grams. And that gives us a value of 0.4698. We need moles of water, which we'll need for mole fraction. "92 grams is the mass for water. We divide by the molar mass, which is 18.02 grams per mole. And we get a value of 5.1054. I'm not rounding these because we'll round at the end for our final calculation. And then finally, the last thing that we need is volume of solution for molarity. So our mass of solution is 100 grams. We're given a density, which is 0.9651. So the grams will cancel, and then we need to multiply by 10 to the minus third to convert to liters, which is what we'll need for molarity. So we have 0.1036 liters. So with all these values in mind, let's go ahead and move on to our concentration calculations. So first is molality. So molality is moles per kilogram of solvent. So moles of ammonia is 0.4698. And then the mass of the solvent we calculated here as being 92.0 grams. And then, of course, we want kilograms, so we multiply by 1,000. Our grams cancel, and we get a value of 5.11 molality of ammonia. So next is molarity. So we have the same numerator, 0.4698 moles of ammonia. Instead of kilograms of water, we now want a volume of solution. So we have 0.1036 liters. So we do this division and we get a value of 4.53 big M molarity NH3. And then lastly, we want to calculate mole fraction. So again, we're using the same value for moles for our numerator, 0.4698. And then on the bottom, we're going to have total moles. So it's going to be 0.4698 plus the moles of water, which we calculated as being 5.1054. So our moles cancel, and we get a value of 0.0843 for mole fraction.